So we'll now continue with the chapter language of chemistry, and we had understood the symbols, how the symbols were framed, and then we also understood that how the compounds are being formed. So accordingly, now we are going to see that how a chemical equation is written and what is basically a chemical equation, why is it written, why is it balanced, and we also studied the balancing of equations. Now, firstly, what is a chemical equation? It is just a shorthand form of a chemical change. So, whatever chemical change is taking place, instead of writing in the complete words that okay, nitrogen dioxide plus oxygen giving me nitrogen trioxide. So, all these things, instead of writing that whole thing completely, we are writing it in a shorter form using the symbols of the compounds. So, the chemical equation shows the result of a chemical change in which the reactants and the products are represented by symbols in the case of elements or formula in case of compounds. So basically the equation will be having two parts. What we will be having will be, so this is chemical equations. So the chemical equations will be having two parts, the left hand side and the right hand side. The left hand side, the RHS over here, are the one which are called as the reactants. So reactants are the one which are going to be in the left hand side, and they are going to form what will be called as products. So whatever is written on the left hand side of the chemical equation are the reactants of that particular chemical equation. So whatever are the different compounds or different elements which are going to be used in the chemical equation are going to be written in the reacting form. So in case of the elements, it will be just the symbol of that element, and if it is a compound, then it will be the formula of the compound which will be there in the reactant side. Similarly, whatever is being formed, whatever chemical reaction what is taking place, and end result of that, whatever is formed, is going to be written in the product side. So the product side will contain the different elements in the form of symbols or compounds in the form of formula which are going to be formed after the reaction has been completed or has been taking place. So we see that the reactants over here are the substances which take part in the chemical reaction, and the plus sign in between. So suppose I give a particular example as NaOH plus HCl. So okay, it's NH4Cl. Take it. We'll take Na this way. NaOH plus HCl will give me NaCl plus H2O. Now if this is the reaction what I'm having over here, then these two are the reactants and these two are the products of that particular reaction. The arrow over here, this arrow over here indicates that it is to yield or to represents that the direction in which the reaction is taking place, that this is forming into this. So this arrow tells you that this was the original thing which formed into this particular thing after the reaction was taking place. So accordingly we have the different kind of equations. One would be that one compound forming into two or three elements or compounds, or it would be two reactants and giving you one compound, or it could be two reactants and two products, like over here two reactants and two products are formed, or it could be two reactants and three products formed. So there could be many things. There is nothing like a strong rules or that if this is two, this has to be two only, if this is three, then this has to be three only. There is nothing like a rule over here. It's a simple thing that whatever the reaction takes place is going to be given in the form of a plus sign to indicate that these two products are going to be these two reactants are going to be reacting, and the products formed will also be given with a plus sign in between, that these are the products which are going to be formed. Now this chemical reaction, when we write the chemical equation, would we write, is not 100% complete. There are many limitations of this particular chemical equation. So when I get a chemical equation in front of me, it is not necessary that it gives me the complete information about this particular reaction that has taken place. There are many limitations. Some of the limitations we are able to overcome. Whereas certain limitations are such that you cannot overcome those limitations, and that limitations will remain, and that is a part and parcel of the reaction, that you cannot identify certain kind of things what a reaction cannot express. So first thing is that what does it tell? What is the information which this particular equation is going to give you? Is firstly the chemical nature of the reactants and products. So the chemical nature of the reactants and products is what the information it can provide you, that whether it is an acid or a base or a salt, it can give you that thing. The nature of element or radical involved. So what are the nature of the radical involved? Now, if at all it is going to be this way, then it is a one-way kind of a reaction. If it is going to be like this and this, then it is a reversible reaction. So it does tell me whether the kind of a reaction is just one way or it is two ways, or it is going to be reversible or not. And thirdly is that the state of matter in which substance is present, that is solid, liquid or gases. The information provided, you can have something over here that you can write over here as aqueous solution, and this one can be, again it will be a aqueous solution, and this you can say it's liquid, this is solid, you can. So accordingly you can always have this particular thing given to you in the equation, that whether it is a solid, liquid, a gas or an aqueous solution, that information can be given in a particular chemical equation. But there are certain things which are the limitations of chemical equation. You cannot know certain things from the equation. The first thing is that the concentration of both reactant and product, you cannot tell that what is you can just write over here concentrated or dilute. HCl is constant dilute, but how much concentration? 40%, 50%, 70%, 80%, 90%. You cannot identify that thing. You can just write over here, like I can write over here, or just add over here like dilute HCl, or I can say concentrated HCl, but I cannot write I don't mention over here as 40% constant HCl or 50% constant HCl. No, this particular thing is never mentioned in a particular chemical equation. So it does not tell you about the concentration of the reactants and the products. Second, it does not tell me about the speed of the reactants involved. ये कितना फास्ट होने वाला है, वेदर डालते ही फटाक से मुझे ये मिलने वाला है, और वेदर ये डालने के बाद 2 घंटे रुको उसके बाद मुझे ये मिलेगा, या तो मे बी आफ्टर 2 days you are going to get this thing. So the speed of the reaction is not known. You cannot identify कि ये कितने टाइम में ये रिएक्शन होने वाला है. So the speed of the reaction is not known. Second, the change in the color. Okay, there are the possibility that there will be a color change taking place over here. In this case, there is no color change, but if at all there would have color change, so suppose this would have been red in color in original thing, but when this is formed, it may be blue in color. So it is not going to tell me that there is a color change which is going to take place. So the color change is not identified, or the change during the reaction. The fourth point is completion of the reaction. It doesn't tell me that after this the reaction is going to get completed, or is it going to happen that this form will again react with this and give you something else, or these two are going to react with something else. No, these two are going to react with each other. No, it doesn't tell me that whether the reaction over here is a complete thing or it is just partially there. It is going to be dependent on only till the time it is heated up, or it is going to continue even if the heating will be stopped. That particular information cannot be achieved by a chemical equation. Lastly is a change in the evolution of light and sound during the occurrence of the reaction. In this case or any other case, you are never able to find out whether any kind of a sound is going to be produced or a light is going to be given out. You can always know that heat is being given because you can write it in the form of plus heat, or you can always write over your heat, that heat is being given to it, but you will never be able to tell whether light is going to be given out or not, or sound is going to be produced or not. So these are certain limitations of the chemical equation. So chemical equation does not tell you, we'll go through things once again. The concentration, whether it is how much is the concentration of the reactant in the product's form. You don't know the speed, how fast this reaction is going to take place. Third, you don't know any kind of a change in color which would have taken place. Any kind of color change is not known. Thirdly, whether the reaction is complete or incomplete, you don't come to know about that. And finally, if there is any evolution of light or sound which is going to be produced during this reaction. So this thing is the information which is provided by the chemical equation and the limitations of the information which can be provided by the chemical equation. So these limitations need to be kept in mind, because we should know that what are the things which our equation is not going to tell us, and accordingly we should be able to learn certain things extra than just the equation. Like I said, we need to know that what is the color change which is taking place, because it is used to identify certain elements. The colors, the change in the colors what is taking place, or the color of the gas which is evolved, is going to be used to identify certain kind of elements which are going to be generated. So that's why color and all is sometimes important. Now we talk about the next part, and that is balancing of equations. Now, in any chemical reaction, if you see this way, that suppose I take a very simple reaction like H2 plus O2 gives me H2O. Very well, we everybody know that hydrogen plus oxygen is going to give me water. Now if I see this particular kind of equation over here, I see that there were two atoms of hydrogen over here, and there are two atoms of hydrogen over here, so there is no problem over here. But here there were two atoms of oxygen, whereas there is only one atom of oxygen over here. So in this case, if this reaction holds good, if this is going to be the right thing what is happening, in that case I am destroying one oxygen atom. Yeah, one oxygen atom is being destroyed by me over here. And we know very well that atoms can neither be created nor destroyed. So if I'm not able to destroy this thing, that means there is something wrong over here. Or I would say that this reaction is going against the law of conservation of mass and energy, because the conservation of mass and energy tells me that matter can neither be created nor be destroyed. So here, if I am using this equation as the basis for anything, it is going to happen that I am going against the law of conservation of mass and energy. Hence what we do is that we try to find out a way by which we are going to see to it that the number of atoms used over here of each and every element, and the number of atoms which is used over here for that the same number of atoms should be equal. So here we see, if I put a 2 over here, that means now I am having 4 hydrogen atoms. So if I put a 2 over here, now here also there are 4 hydrogen atoms, and now there is only 2 oxygen atoms, and this is 2 into O will be giving you 2 oxygen atoms. Hence I can see that now the number of atoms over here and the number of atoms over here of each and every element is balanced, or we can say that each and every element के जितने भी atoms use हो रहे थे reactions में, the same number of atoms are available even in the product side. Hence this process of balancing, or this process of equalizing the number of atoms of each element on the reactant side to be equal to the number of atoms of each element in the product side is called as balancing of equation. And this is done so as to follow the law of conservation of mass and energy. So that is why we see the balanced equation is one in which the number of atoms of each element is the same on the side of the reactant and at the side of the products. So why should we balance it? Is all equations must be balanced in order to comply with the law of conservation of matter, that which explains that matter can neither be created nor destroyed in the course of chemical reaction. An unbalanced equation would imply that atoms have been created or destroyed. That's what exactly the example I gave you. So how to balance this particular equations? balance the equations, what we are going to use will be firstly what we already learned even in the 8th standard, and that is the hit and trial method. Now hit and trial method is the one in which you are going to write each and every compound, each and every element present in that particular product side and the reactant side, and then you are going to balance them. So let's take an example over here. We'll take an example which is, okay, let's take the example over here that ZNS plus O2 giving me ZNO plus SO2. Now, what we are going to first do is that we are going to write all the elements which are present over here. So that is Zn over here, S over here and O over here. We'll then write what are the reactants में कितने atoms है and products में कितने atoms है. So the reactant side, the atoms are 1, here it is 1, S is 1 over here, S is 1 over here, O over here is 2, whereas here it is 1 plus 2, that is 3. So I need to now balance this. And now to make this equal, okay, I have taken an example which was slightly on the higher side, so I'll give you that example also right away. Now because this and this are equal, so I need to somehow make this 2 into 3. What will I multiply this to make it 3? I can multiply it by 1.5. If I multiply by 1.5, automatically it becomes 3. So that means if I am able to put this as 1.5, then this equation gets balanced because Zn will be 1, S will be 1 and O will be 3 over here, but 3 over here. So it gets in balance. But we know very well that we cannot balance an equation by putting a decimal value. The balancing will always be whole numbers. Okay, balancing will always to be done with the whole numbers. So it's a simple way now. What we'll do is that we will multiply each and every by 2. So this becomes 2ZNS and this 1.5 into 2 will be 3. This is 2 and this is 2. Now we can check it again. Zn is 2 over here and 2 over here. S is 2 over here and 2 over here. O is 6 over here. So this is 6 over here and here it is 2 plus 4. So 2 plus 4 is equals to 6. So hence this equation is balanced. So this is a kind of method in which you are trying to see to it that you are balancing it in a fraction first part, and then you are converting everything into whole number. That is also one kind of doing it, but the method remains the same, that you are going to find out for each and every element and then each and every compound or element, and then you are going to balance it on both sides. Let's take one more example over here. We take the example KHCO3 gives me K2CO3 plus H2O plus CO2. Same way, we'll take K, H, C and O. Over here it is 1, 1, 1 and 3. Over here it is 2. C is 1 plus 1. So H is 2 over here. C is 1 plus 1, that is 2. And O is 3, 4, 5, 6. It is 6 over here. Okay. So now first thing is that since I see this as 2, the main thing what I can do is I put a 2 over here. If I put a 2 over here, this becomes 2, this becomes 2, this becomes 2 and this becomes 6. Oh, that was easy. The moment I did this, it automatically got balanced. So this is the solution to this one, that just putting a 2 over here balanced the whole equation. Is it clear? So let's take one more example. We take example over here that NaOH plus Cl2 gives me NaCl plus NaClO plus H2O. Okay. So we have got first of all Na, then O, then H, and then Cl. Over here 1, 1, 1 and 2. Over here it is 2, and then it is O is 1 and plus 1, 2. H is 2 over here. Yeah, 2, and Cl is 1, 2 over here. So as we did earlier, we are just going to place, because this is 2 over, 1 is over here, so make it 2 over here. The moment I make this 2, what will happen? The moment I make this 2, this becomes 2, this becomes 2, and this becomes 2. Oh wow. Unfortunately or fortunately, I don't know. They are taking some examples which are turning out to be very simple. Let's try one more. So this is the answer, that NaOH plus Cl2 will give you NaCl plus H2O. This is just the answer. We didn't need to do anything further. We'll take one more example. Let's take something. NaHCO3 plus H2SO4 gives me Na2SO4 plus H2O plus CO2. Okay. So again the same thing. NaHCO, H is already there, S, O is already there. So 1 over here, H is 1 plus 2, 3, C is 1, O is 7, and so it is 7, yeah, 3 plus 4, and then finally S is 1. I'm writing it 3 plus 4 because if I take a 2 over here, then it may change. That's why here also I'll put it as 1 plus 2 so that I can change it easily. So this is 2 over here, S is 1, O is going to be 4 plus 1 plus 2, so that's 7, okay. H is 2 and C is 1. So I can see that the Na is not balanced. So first thing, now always I will first do is try to balance the metals. The metals, if you try to balance, it's always easier. And the last thing to balance will be hydrogen and oxygen, because normally hydrogen, oxygen are spread in different places. So it's always better to use the metals first. So here, if I take this as 2 over here, this becomes 2, this becomes 2, this becomes 2, and this becomes 6. Right? Now, what happens? This is 2, this is 2, but this is, no. Now we'll see with C. C over here is 2 and 1, so I'll make a 2 over here. So this becomes 2, and the O becomes 4 over here. Okay? Let's take S. S is equalized, not a problem. So now we'll take the H and O. H over here is 4, but here it's only 2. So I need to put a 2 over here. So this becomes 4, and O becomes over here 2. So now this is 6 plus 4, 10, and this is 4 plus 4 plus 2, 10. So this is also 10, this is also 10. This is 4, this is 4. So it is 2, 2, 4, 4, 2, 2, 10, 10, 1, 1. So here it gets balanced with 2 NaHCO3 plus H2SO4 will give Na2SO4 plus 2H2O plus 2CO2. So you can see that here we went on balancing one by one. We tried to balance. What do we balance first? We always try to balance the metal first, then the non-metal like S and C, and then we go for H and O, because you can see H and O were in multiple forms. Because you have multiple places, you need to change those things again and again. So that's the reason you will always find that it will be easier for you to solve it in this particular manner. Now, as you go higher, or else as I said, now in case of your further things like in the 10th standard and all, you will not get time to balance the equation and take so much time to balance an equation. Hence, what is required will be, you will have to keep everything in mind and accordingly not practice using this particular kind of a method. This method, of course, you will need it only if it is too complex or you are not able to do it on your own directly. Otherwise, you will try to avoid this thing. Like for example, if I am taking this next question over here, and that is NaOH plus H2SO4 gives me Na2SO4 plus H2O. Now this is the equation over here. What I'll do is just first of all I'll see Na over here, Na2 over here. So definitely I'll need to put a 2 over here to make it Na2, Na2. Now I will check with S. S over here is 1, S over here is 1, so no problems, I will not need anything. Now I'll take with hydrogen. Hydrogen is 3 over here, here it is only 2. So we'll check this out and sorry, here it is 2 plus 2, 4. Here it is only 2, so I'll put a 2 over here. That makes it hydrogen 4. And finally, I'll see oxygen, that is 2 plus 4, 6. Here is 4 plus 2 is 6. So here we get the balance over here like this. So I need not write everything. I can directly check it over here. After doing this, I can check it once again. Na2, Na2. O is 2 plus 4, 6. 4 plus 2 is 6. And H is 2, H2 and H2 over here. So that is H4. And finally, S will be 1 and 1. Got it? We'll take one last example for this one. Let's take Fe2O3 plus Al gives me Al2O3 plus Fe. We'll start with Fe. Fe is 2. Here it is 1. So I need to put a 2 over here. Sorry, put a 2 here. Now O is 3 over here, O is 3 over here, not a problem. Al is 1 over here, but it's 2 over here, so I need to put a 2 over here. This balances the equation. Fe2O3 plus 2Al gives you Al2 plus 1. So quite easy. Now we'll take one more example because this was quite easy. This is Mg3N2 plus H2O giving me MgOH twice plus NH3. Okay, Mg2 plus NH3. Okay. Now first one is Mg3. Here it's only Mg, so I need to put a 3 over here. Next thing, N is 2 over here, N is only 1 over here, so I need to put a 2 over here. Right? Now what happens? So this N are clear. We talk about hydrogen and oxygen. Hydrogen over here is 2. Over here it is H over here is 2 into 3 and 6. 6 and even 6 over here. 6 plus 6 is 12. So to make this 12, I need to put a 6 over here. So now H becomes 12 and here also H has become 3 2s are 6 and 3 2s are 6. 6 plus 6 12. Oxygen over here is 6. Over here it is also 6 because O2 means N2 3 will be 6. So this is the balanced equation. You need to practice a lot of this thing, but you can see that every time it is quite simple. Only in a few cases it may happen that you are going to get stuck up because if you increase something else, something else is going to decrease and so on. So if such a thing happens, then it will be a problem that what is to be done. Otherwise, normally you will find that the sums are easily available to us.